Coffee water.
Coffee. Some bean water.
Electrolytes.
Yeah. I do not have a backup today. Welcome to Solidworks Live. Mike Sandy, how are you doing today?
Good. How you doing, Michael?
Awesome. I know we got the two MSs today. This is an event to be celebrated. We've got some exciting stuff to go through. We're going to get going with it in a few minutes. But before, I think, welcome, hang out, start asking some questions in the chat. Eric, great to see you back here again, representing the Pacific Northwest. Thank you. Looks like there's some questions flowing in there. So chat it up, guys, in the chat. We'll be reading that periodically throughout the stream. So, Mike, before we kick this off, what do you want to chat about today?
I want to share a certification I recently got that I'm pretty proud of. You know, I think we all know like the certification program with SolidWorks. This one was all of outside of that, but I definitely want to go into it because it was about a year and 4 months of hard work, and I was presented with this yesterday. You guys ready?
Year and 4 months. Let's see it.
I am number one daddy shark.
Yes.
Yeah.
Yes.
So I got that. It lives right on my monitor. Good reminder. Makes me feel awesome. Strong, powerful. So yeah.
That eliminates the whole debate of left shark, right shark. You are the number one daddy shark.
Yeah. And everyone on the stream right now, they can, today say, wow, I watched this. I saw the number one daddy shark. I actually got to chat with him in person. So
you need to tell me more about this. Because the other thing that I'm like thinking of right now is the song, the baby shark.
Yeah. That's it. Yeah.
Is that related to that?
That is where it's from. Yeah. So now I'm gonna have that stuck in my head this entire live stream now.
Sorry, everybody. We're gonna bring it back. So okay, yeah.
We actually see if the producers can stream that in the background, so we just all go progressively more crazy as this continues.
I don't know if we have the rights to that song, but we'll see what we can do to get something.
Oh yeah,
again, right? It makes me think like my kids know the hand motions too. Of like the grandpa shark is my favorite.
No teeth.
Yeah, no teeth.
Outside of that, man, just we had snow yesterday. I don't know, how's the weather out where you guys are at?
Oh, we are getting some sunshine. See, right now is the time that you don't want to tell other people about in Seattle because it's so beautiful, clear skies, excellent weather.
This
typically
week? Just the one day of the year, or is it this week of the year?
It's the one day of the year. That's exactly right. No, it's supposed to ramp up and be really nice. It's supposed to be a beautiful weekend coming up here, and get outside, enjoy the sun. Yeah, it'll be good.
Sweet, that's awesome. Yeah, we had snow yesterday. We got my daughter out to play in the snow one more time. Pulled her around in the sled around the yard, and in Minnesota we always say this has got to be the last snow. Which is a guarantee that it'll snow again next week. So our weather is cold. July is really, really hot, and then cold. We can't figure out why July is always so hot, but whatever.
Yeah. Welcome to the show. Yeah, it looks like you got a good question. So I think we can start talking about some of this now. So this is SolidWorks Live Design. This is the second season. We did this last year, bringing together a bunch of talented folks across SolidWorks and presenting some interesting either home projects or something that we've done in industry just to showcase some use, and so you can learn some tips and tricks using SolidWorks. There's a great question in there of, what playlist should I start from if I'm a beginner going on to, more advanced topics. Looks like we did get a reply back in there. So scroll up in that chat. There's a playlist that we've linked to. And you'll see, if you search for SolidWorks Basics in YouTube, there's a variety there. The other place that I would recommend going to is my.solidworks.com. There's some great learning content there that you can kind of go through, and it covers introductions up to advanced topics. So, yeah, and that's kind of where I think the content that we're going to talk about today, Mike, is a little bit kind of on the intermediate side. Would you agree with that?
Yeah, I think what we're going to go through today is, it's getting assemblies ready to go into some simulation side of things. But a lot of just UI and tips and tricks is what I plug in here on things that you're going to use outside of prepping for simulation, just in your design. So, if you're not a sim user, maybe you're looking to be, or you just don't do it yet. Hopefully you'll still get some tips out of this. So
well, definitely, if we're doing assembly work and looking to simplify an assembly and like reuse that kind of in downstream efforts, if it's simulation or building a much larger assembly, I think we're going to learn some good things. You mentioned simulation, and actually, I want to reflect back to the last time I was on Live Design this season a few weeks ago. I covered some of the simulation capabilities in Simulia, which is a sister brand of Solidworks and Dassault Systèmes. Where I did do a little bit of simplification of an assembly and of a part using some of the Simulia tools, but and maintaining the references and maintaining the tie directly to SolidWorks. Today we're going to take a different approach and kind of a different attack at this. I mean, if I remember, Mike, can you describe kind of the situation that we're in today?
Yeah, so kind of the backstory, and I'll introduce the model as well. Before I came to SolidWorks, I worked for a reseller, and I did a lot of training in the simulation class. It's a 3-day class, which doesn't lend itself a lot of time to get into bigger assemblies that a lot of our customers deal with. So a particular, Jesse, if you're on, hey, what's up, man? He came in, and at lunchtime, I always challenge him, like, bring in your models and we can go through it together. And what he brought in was this pipe lifter. So this is it's an end of an excavator arm. This thing picks up. This is actually a railroad tie, a log, but designed for huge pipes. And it can articulate them 180 degrees, rotate them 360 degrees. It has additional arms that will turn them, so it can screw pipes in. Very accurate on positioning, and very complex model, right? He brought it in, the full hydraulics are all in this thing, all the electronics, all the sensors, and he's like, I've got to get this thing, and I got to get a factor safety out of it before we can go and actually put it into production. Where do I start? I said, oh man, that's because in simulation training, everything is kind of ready to go. So that's kind of where we got, was like, well, what are the tools available in SolidWorks that lend themselves to be very friendly for, getting a model like this ready to go to production. And I only took a sub-assembly from what we just saw for the sake of this video, but we walked through with all the arms, all the hydraulics, all the attachments, and really figured out some cool workflows. This particular power user in SolidWorks CAD, so I got to give him some props here, because he taught me a lot of things too as we figured out some methods. So that's kind of what we're going to dive into, is like, I've got a fully detailed assembly and I need to get it less detailed so we can get some numbers on a simulation to say it's safe enough to put into production.
Yeah, I'm thinking of some of the other projects I've worked on, of like, if it's the first one I think of is one of my first projects of designing some, lifting. We weren't lifting pipes, but it was for lifting other heavy objects, and it was actually needed to be, I think, factor safety of 10 for being an overhead device, and it was just amazing. I mean, being the first project, like the other engineers I was working with, it's like coming at this and trying to attack it in different ways. And it's like, there's no way you can manufacture some of the things that we were coming up with, right? Because that's the other challenge is, sure, you can design it to be strong, but is it manufacturable? So we can talk about that on a future episode. But yeah, today, like you said, it's all about, okay, we have an existing design. We need to get some simulation results as fast as accurate. I mean, I think of Model Mania. If any of you are familiar with Model Mania, it's a design challenge that happens every year that's happened at SolidWorks World and 3D Experience World for over 20 years. And the situation is, right, you sit down, you get a drawing, you make a part. After you make that first part, you're given a change. And it's like the fastest, most accurate and fastest time wins.
Just got to go, right?
Just got to
I don't care. I'll hack at this thing. I just need to get the right answer because the clock is ticking. And it's the same thing here, right? We have the production model, it's detailed. Now we just got to get this verification so we can go. And that's, we'll hit on all that.
All right. So should we take a look at the model?
Yeah. So where do we start? I at this point, again, this is just a sub-assembly, but this is their production model. And the first thing I always do when I'm putting on my analyst hat is really start to look at, and if you got a little background in CAD, you can start to look at how this is actually put together. This particular model, as we go through and kind of investigate the tree a little bit more in detail, we see that they've separated out all of these plates to kind of the stock material. So if I open up this particular base plate, this is a 2-inch thick, heavy stock material, right? That they're going to use maybe a water jet, plasma cutter, probably a plasma cutter to get this thing cut. 2 inches thick. That's crazy. I can't imagine what that thing weighs. And then in the next level up in the assembly, I've got some display states that are going to be popping around here. You'll see that they've actually added all the machine features into that subassembly. So as an analyst, spend a minute, say, well, what can I right away get rid of, and just by suppressing and so on. And I'm going to skip this part because I want to make it a little bit more difficult. This is a very well modeled assembly. They approached the weldment side of this thing correctly. They have the stock material, they have the machine components put at the right levels. It makes it manageable, but that's not always the case. So we're gonna take a little bit different approach. So yeah, just spending a minute, click around, take a look at it, see what's going on. But the next thing I like to do is figure out what's my file management side of this with Sim, and if we're doing that really fast, hack this thing apart approach to it, we don't want to worry about making the CAD designer or completely blowing up the production model. So one way you can actually approach that is configurations. I personally come in here and I'm going to do a pack and go. So if you're not familiar with a pack and go, I'm working in SolidWorks 3D Experience, or 3D Experience SolidWorks Connected. So it shows as expert SolidWorks files. On the desktop version, you'll be able to do file and just do a pack and go. Let me save this real quick. But what this is actually going to
That's a really good point that you're bringing up, Mike, is like while you're doing that is, the version of SolidWorks that you're using is SolidWorks Connected, built on the 3D Experience platform. So your native save operations are kind of being done to that 3D Experience cloud platform. But you're going to go through some clicks, and I think you can call them out while you go through here. I'm sure a lot of people watching use the traditional SolidWorks desktop. Yeah, just call out a couple things that are going to be different here. What
Sure.
What would they click on as they would go through it in SolidWorks desktop?
I wanted to make sure that the folks out there that are using the desktop version get those clicks to it. So on this one, though, what we do have is, because all my data is on the cloud, that's what you're seeing on the right-hand side. So the 3D Experience Connected side, storing everything, has that version on the cloud. I can get it anywhere, pull it down. So right now, I'm just making sure this updated version, I made some changes this morning. That's why we have to make this save. But then I'm going to export these out. So even though this connected version, which is still a desktop, this is running on my desktop, just connected to the cloud, to my PLM system there.
Yep.
We can still take and export this out. So the pack and go.
It's a really creative thing there that happens is in that when you have to do it like an export, it checks you. It says, well, if you want to do an export, we want to make sure that this is an accurate export. Mm-hmm. Like, have you saved the proper changes internally before you export this, so that at that time you have a one-to-one? But of course, everyone knows, like, as soon as you either print a drawing or send something out, it's kind of immediately out of date. Yeah. But for this purpose that we're going through, sure enough, we're kind of ripping that out. We're going to be hacking and slashing away at it to do this as quick as possible to get to some simulation results. So this is going to be exciting.
Yeah, it even just prompted me and made sure I reserved all the components. That way, if no one else was working on it, again, making sure latest and greatest. So what you see here, this is the pack and go dialog. This looks the same on all the versions that are out there. But I always recommend go through and add a suffix to it. And what we're grabbing all these referenced files, and they could be all over the place on your server if you're using that, or in SolidWorks PDM, which manages those references. And I like to make sure we're creating a new unique name to those, and then putting this somewhere very safe. Again, we're trying to completely cut the tether to the production model, and we're putting that over. Now, Michael, you and I were talking about why is this good? Why is this bad? And I think one of the things I really want to focus on is, as you're doing this method is really intended for that kind of ready to go to production. We need the final check in Sim. Mm-hmm. You really, really, as you're evolving the design, simulation comes into play a lot of times to be able to do it with that design as it gets to this point. If it's just that final sign off, are we good to go? Grab this. We're creating just a verification model to run the simulation, run the report, and then attach that over to that final. And you can zip that up, bring that over to the production model and have it as a reference as well.
Yeah, and we're kind of approaching this internally as if kind of like this is our own company and this is the model that we're working on. But I could imagine, similarly, if you've contracted with someone out of house running the simulation, it's like, okay, pack and go, here you go. And I can't count how many times it's happened to me of like I receive an assembly file and it's just the assembly, like it doesn't have the parts inside. So that pack and go is a great solution. Pack and go is the solution to package everything up, make sure you get all those references.
Yeah, and you'll notice on the desktop version, there's some options too, like include toolbox components, include decals and stuff like that. So you can just make sure to walk through those as well. So I'm not going to do this step. I don't need to. I just want to make sure you guys are all aware. It's worth the extra step in time. Save this out to a folder, to a zip, add that suffix, and just double check that the new title, has been brought in here. So that's Pack and Go. Awesome tool. Has a lot of uses outside of this. Now, once we've got this ready to go, the hack model, right? Ready to really just dive in and tear this thing apart. I've looked at it. I've understood it. Where we started to go with this one, especially with the whole assembly, was suppressing out the components we don't need. And a lot of times it's just like figuring out, what don't I need? A lot of times we're going to replicate fasteners inside a simulation. Large pins can replicate it virtually. But in this case, like if I zoom in, we have a lot of like the hydraulic manifold. I'm not running a sim on that. The mass, when we're looking at tens of thousands of pounds of force, that hanging there is not going to make much difference. Some of these are pins and clips. So all of that stuff, right? That's just adding complexity to the model that when we go to sim and we need to create the mathematical form, or you guys probably all heard the term meshing the model. You don't need it. It's just adding time and computational time and going to give you struggles. So we're going to get rid of it. Now, here's a trick that I learned. And my first big trick to show is instead of going through and, suppressing these out, which I think most of us would probably attack, what I'll do is actually hide them. And the reason I start doing this is it's faster to unload these from your graphics card, which is hiding, versus having to suppress it, which is clearing it from the memory. In large assemblies, when you're doing this in bulk and you have a lot loaded to memory and you're unloading stuff from memory, every suppress, you're going to notice there's a little bit of a time.
Yep.
So doing things like click on the manifold, I use a right click menu. You can take and hide component, or awesome hotkey is just hitting tab.
Tab
and you'll
to
notice, hide. Tab to hide. And you can start to just go through and tab out things you don't need. Like I'm going to replace out a lot of these washers we definitely don't need. And this is where you can start to be pretty quick. Just tab, tab, tab. Then you get other tools like being able to do, for users out there, left to right select. If you're not aware, that's a blue box. And that left to right select versus the right to left select, left to right or blue, that's everything inside. Right to left or green is everything it touches. So having that tool, right click and hide that out. Again, just using my tab, and a combination of these, I can start to go through and just get rid of all of these components. It's a much faster way, much faster workflow in large assemblies to get rid of the extra data that we don't need.
So this is good. So you talked about hiding components, but I can imagine, we're going down this path, but I just want to rewind for a second for every SolidWorks user out there. It's like, if you didn't know about tab to hide, and if you do, go ahead and give us a +1 in the chat. Or if you didn't know about tab to hide, just let us know that, oh my gosh, you can, hit tab on the keyboard to hide a component. But what's the keyboard shortcut to show?
So maybe you get rid of something, and in this case, a big structural component. No, I needed that. Shift tab, right? So you hover over that spot, shift tab will bring it back. Just know those two: tab to hide, shift tab. And this works in multi-body, which we'll get to multi-body here in a little bit. But for me, I love using tab to hide. I use it all the time. Now, Michael, I got one for you. What if you do a bunch and you don't even know where to hover over? How do you get those back?
Oh, let's see if I remember the dexterity. Is it Control Shift Tab?
Control Shift Tab. Yep.
Got to hold it. And then you kind of get the temporary display of all those components, and you can click on the ones that you want.
Yep.
Right?
Okay. That's right. So Control Shift Tab is a hotkey. And what that does, I'll do it again here, is that will temporarily bring up items that you may have hidden, and you can just click it while that's active. I think for the users that have been around for a while, you all know that the show hidden components as well. So on my assembly tab, what this actually does is it inverses everything. And here's a kind of a gut check. Did I hide something? Well, the main structural plate. So once that show hidden is active, then when you select on a component, this will actually bring that back into that hidden state. So again, a couple different options, just the Shift tab to bring it back. You got to know where it is. So like I knew this one was right here. Control Shift tab to temporarily bring them up, or just the hide show, and then you can click them.
All right. So while you're cleaning some things up there, there's some good dialogue going on in the chat right now. Good. What's the best way to cut material? And I know Eric's in there. He's repping the Omax. That's actually something that we featured in a previous What's New. So if you can see kind of a whole string of content in SolidWorks What's New using the Omax water jet machine, awesome technology. Yeah, there's also, going back to the kind of the 3D experience platform question of how secure is the cloud. And if you have that question, Mondo, I see you there in the chat. Head on over to 3ds.com. There's some white papers that talk about the security and how, Dassault Systèmes is implementing state-of-the-art leading technology to make sure that, even if you get on 3D experience platform, you're on the public cloud, you do have, if you set up your own environment, it is secure to you. Of course, if you need additional security on there, there's on-premise solutions. And different types of configurations for that if necessary. So it comes in different flavors, I guess I can say it like that, to hit the security benchmarks that you need. All right. So how, Mike, there's a lot of small components that are in there. Do you have any other tips for how to easily select some of these components or find ones that we may not want?
Right, because speed, we don't want to sit here and just tab. That method will get you a lot of the bulk stuff, right? I know this whole hydraulics unit that was hanging off the bottom. I can just window select that, tab out some of the bigger things. But man, I don't remember when it was when I ran into these, but these selection tools, which have been added to in recent, I think back. Even recently we had the select identical components, wasn't too far out, but check these out if you're not familiar with them. If you're using Toolbox today, you can just group and grab all your Toolbox items and do one big hide or one big suppression, select by Toolbox. I love the select by size. This is probably one I use a ton of time, very often. What this does is it looks at the overall assembly and it does a percentage of that that size. I believe it's based on Bounty Box, but correct me if I'm wrong. I'm not 100% sure. But anyway, so that goes in and that will take and just grab any of these smaller components, which again, in this case, structurally speaking, we're not going to need these. Structurally speaking, we'll need fasteners, but again, we're going to replicate those virtually in simulation. So I just use that select by size, and just like that just blasted out a bunch of different small little things, really getting me down to just going back to my tab key, tab, window select, and so on, start to hide these out. So great question.
Again, these are components that don't influence much of any to the structural integrity of what we're getting to analyze today.
Right. If there's anything you do question that may or may not, bring it along, right? We can always, as we go through this workflow, my end goal here is to actually create another version of this. We're going to have a part, multi-body part. So if you're questioning, well, do I need that or not? You can bring it into Sim. You can run an analysis with it and run it without and see if that actually affects the overall displacement or stresses of the part. So if you're questioning something like, hey, maybe this pin, does that affect the overall displacement? It might not. You can always bring it with you.
Yeah. And I know as a simulation user myself, I've run into many cases where you start too complex and you're trying to troubleshoot the model a little bit. It's always easier to start simple and then add complexity from there. Would you say that's
crawl,
fair?
walk, run. Yep. Crawl, walk, run. Crawl, walk, run. a sim, it's like get down to your structural side of things. Let's get it to run. Are we getting some sort of results? Does it make sense? All right, now let's start to add in that complexity to it. So Michael, we talked about the pack and go up front. I think another very common tool is to create a configuration. If you're doing part simplification for FEA, you got a complex single bracket, but you want to get rid of holes and fillets and those things. Configurations are super awesome. In this workflow, what I found super handy because we're hiding is display states. So if you guys aren't familiar, under the inside of configurations below that are display states, and these are really intended to manage the look of that, but it'll manage what's hidden and shown, which is what we care about on this workflow. It'll also manage like transparencies of this and so on. So what I actually did is I created a sim display state that right away, and I went through and I started to create, or hide out all these components, and now I can toggle between that first display state, which would be everything shown, and now my sim display state, which is all of the the stuff that I want to actually simulate.
Well, it looks like it's even captured colors.
Yeah, so we'll actually that leads me to the next part of this is we're going to create another part that we want to carry this along in a simulation. And what I've done here is I've added some red to these plates. I got two that are colored. We won't color the rest, but really the objective is, now that I've got it detuned in terms of complexity in the assembly side of things, I've got all that stuff gone. Now it's understanding how I want to set this up in simulation. And Michael, you're a sim guy. Do you want to, I guess, on the mixed meshing thing do you want to explain that? I know you did a job with it.
Just one moment before we get into some of the meshing conversation. I just wanted to plug display states one more time, because you're using it to kind of, control, what's hidden shown, and maybe do a little bit of color coding for managing the model. But one of the other big benefits of display states is, I know I've seen many times, a lot of people create configurations when they're not necessary. Display states are a faster, kind of lighter weight way to control hide show as well as color states. And, Mike's doing some of that here. But if you have a product and you want to show it, how it may come in different, colors, display states is the way to go. Like, I got a green version, I got a black version, I got a yellow version. Display states is an easy way to capture those visual properties without creating extraneous data.
I've seen it used for vendor sourcing, color coding by vendor sourcing, color coding by location of vendor sourcing, which is a manual approach. And a quick plug for Innovia and on the 3D experience with the basic, or the CSV, our industry
collaborative industry innovator.
Yeah, they've got a really cool way where you can visualize your entire CAD model, and it automatically paints everything by like who the is it built in house, how is it manufactured, where is it from, what's the material. So there's actually some automation too to check out. So your local reseller can definitely show you that, but we should do
I gotta say. Yeah, and because a lot of those are based off of like custom properties about those products to automatically color code them, which you can also do with assembly visualization inside SolidWorks as well. So you got tools, but if you do assembly visualization, you need a seat of SolidWorks to do some of those processes. With the 3D Experience platform, it's on the cloud. You can do that filtering and automatic color coding directly from your web browser. So powerful technology, kind of both ways, depending on how you want to work. So meshing. Okay, so with SolidWorks simulations, there are three types of mesh. There's a solid, beam, and shell. So shell is kind of the first thing that I think of when I see a lot of these plates. And when if you haven't used simulation before, like, why do I care about these different types of elements? Well, sure enough, you could just kind of treat everything as a solid mesh. The downside of that is the computational requirements. How long is it going to take to solve? Especially for thin-walled components, using the shell mesh type is much more efficient and takes less time to compute, but still maintains a good level of accuracy. So I think that's what we want to do here for some of these plates, right? So
we'll get a little more into that. So I wanted to, thanks. That's a great explanation. So what I'm doing is saying, well, what is my strategy? And in this case, it was like, I want to use those shells that Michael, you're just talking about, because they are so computationally light. They solve fast. They're very efficient. And in this case, I'm just kind of going through and saying, well, these plates, these kind of these ribs are all about the same or they're all the same thickness. So stock plate material. So I'm just making a note just by coloring it red. This giant plate here, that was that 2-inch thick stock plate that came in that has actually been machined down. You can see, how they've machined off the top of this, not uniform thickness. So that one's going to have to be a solid element. This plate here, this is all uniform. This is actually a 3/4 inch. So I may just, take a second, come in here and grab that body. You guys are learning how the appearances apply. This is a really nice little reminder of the hierarchy. So right now, part is at the very bottom as the lowest priority when these appearances come. So I can leave that gray on there. The actual body itself, then the feature, then a face, and then the assembly. That's how appearances override. So if you're ever playing with these and you're confused, no, I just colored this pink, it's not turning pink. Click on it. You can check the hierarchy and see where those colors are. So in this case, like on the body, let's go ahead and click that. That'll bring up my appearances on the left. And we'll just say, hey, 3/4 inch plate, we're going to call that green. All right. And click the OK. And now that's applied. So this doesn't have a lot of different thicknesses to it. But it's just kind of giving me a game plan, because my next operation is creating an actual surface body to represent those. So again, I'm thinking ahead. I'm not in simulation yet. You can do some of this in simulation, but we're not using a license yet. I'm using all CAD. And now I'm going to actually create a variation of these with some surfaces.
All right. Before you mentioned surfacing and creating surfaces here, before you get into some of that, Mike, I got to ask the chat. I got to ask our audience, because we're going to cover some configuration in the SolidWorks options. And because there's a setting there where you can change the open edges of surfaces. So chat, what color do you want Mike to change the edges of those open surfaces to? Right? What do you think is going to look good, chat? What do you think? Maybe do you think gray? Gray's just going to blend right into the solid.
Transparent. Is transparent an option?
What color would stand out there? So Mike, go ahead and continue while we get some of those answers in there, and I'll tell you who's which color we should pick.
So we've got, kind of just to back up, detune this, got rid of all this stuff. Now we're starting to strategize our mixed mesh, solids, shells. What am I going to use to speed up that program? I've painted these to kind of, say, hey, this is 1/2 inch plate steel, 3/4 inch plate steel, make a note, go through. Now it really comes into creating that surface variation of it. You can do it in sim. To me, this is the better way to do it. So what I'm going to do is come in and actually create a new part. Okay. We're not going to do anything to the, the basic one. And we'll just call this shells. We'll save that new part. And now I've got a part I'm going to working in context of the assembly. This part is going to build all the representations of the plates in that shell form, or that surfaced form. So when I say shell and surfaced, surface is like the modeling tool that we use. It's a shell inside a simulation. So those work interchangeably. Okay. So new part, I'm going to be working in context of this part. Let's give that a reference to the front plane. And right away, I'm going to come up to my surfacing tools, and I don't need any sketches. So you can, by default, SolidWorks always goes to that sketcher. And we're going to start using the offset surface tools. I don't know why I lost my display states, but we'll just work through it. And I know what's going on here. So
since we're editing in context, it kind of paints everything else, backwards. And you can force transparency and do other things like that. But you're getting into some offset surface. Okay.
Yep. So on this plate, these flanges, these are uniform thickness, and this was a 1/2 inch plate. So I'm going to give that a 0.25 inch. What I want to do is I want to create a surface right in the middle of it. Simulation is going to, in the back end, in the math, we'll add that material, but we don't need to actually represent it in the mesh. They can do it in the equation.
Yeah, because at this point we've both run simulations before, but if you haven't run simulation before, and we talked about these different mesh types, there's still this outline question that we haven't been able to show you yet of how do you define if you're going to be solid, if you're going to be shell, if you're going to be a beam mesh type. In those options, we can explore those later on, but you can right click on components, you can define shell by a solid face, you can right click on something and treat it as a beam, or toggle it back to a solid. So there's different techniques there to work with. What we're going through now is actually when SolidWorks simulation sees a surface, by default it treats it as a shell. Right, so that's why we're creating these surfaces. It's like we don't have to go through other manual steps later. We're doing those steps now to prepare this model by creating some shells.
Yeah, and the other thing we'll show you
surfaces
in just a little bit is we got to like glue these things together. We're going to weld them in simulation. Yep. When I have this solid or this surfaced version of it, it's a lot easier for me to remember where to pick the edge because there's just one edge. So we'll point it out too, but this is to me is a really key part of the workflow. So now it's just going through and grabbing what I know are uniform thickness plates that will be a great fit for a shell. And there are tons of threads out there on this. You can get onto the forums. You can, on engineering.com. We didn't invent shell elements or solid elements by any means. This is a common discussion in FEA. So, just Google it, check it out if you're not sure, and you can learn plenty more. And obviously the SolidWorks simulation class, they go very in depth into this. So I'm going to go ahead and create one of those shells.
Oh, hang on.
I'll get it back. Yeah.
Okay, because it happens so many times of like, okay, we get a pop-up and we move on, and then you ask the question, why wasn't it working? Okay.
So let's see it again. All right, here's a tip that I want to show you though. Your enter key, if you're not familiar, your enter key brings back your last used command. And that's really helpful here because it brings up that offset surface tool. And another tool I use here is the right click and then select Tangency. So two of those in there, you'll notice it just grabs that whole tangency, come through again, make sure we're offsetting into the inside of the plate, and then click the OK. And here's your error.
So if you take a look at the top left, I see they have an option on no external references. What does that mean?
So right now, this part is in the context of this assembly. It's a fresh, nothing to it geometry. But I'm now referencing another set of a different geometry set, right? And that's where this is being created. I'm currently working in this no external references, and we had this conversation just a few days ago about, hey, where do you go with this or where are you not? In actuality, in this case, I should have this option disabled. I shouldn't be getting this. Reason being, if this plate ever changed, and I don't have I have external references turned on, this shell would update as well. So I would get that change. I think best practices we often see when something is going to be released, you go through and you break all of these external references. A lot of your CAD admins can kind of answer that. A lot of forum chat on best practices there. As a designer, I personally prefer to work with this turned no external references on until I know I want that design intent. Then I go in and turn it off, knowing that part's gonna have design intent. So you'll get this. We'll ignore it for now.
Yeah, that's a really good point because it's reflecting back on our initial challenge today. It's all about performance and speed. Turning off no external references means that as you create other features and the model rebuilds, it's not having to check the assembly when it rebuilds these surfaces. It's nope, that's the surface, move on.
So if you're doing this workflow earlier in the design phase and that assembly is going to be going through changes because you're doing the if then type simulation, well, maybe the plate needs to be longer, wider, whatever, have that on and you get more automation to it. But this one, we just need to make sure that we're meeting that factor safety of 5. So using these offset surfaces, creating, I don't need to have that external reference turned on.
Nope.
All right. So Michael, I'm going to create 2 more of these real quick. So again, just right click, select tangency. My enter key should bring that command back up. Not doing that right now, no big deal. And I'm going to do it for this plate as well. But what's pretty cool is this model here, if we again remember, one of the requirements was unified thickness to use these. Not everything has that. The main tongue that comes down here, this main fork, this is machined down. It's not unified. So that one has to be solids. Okay. So again, what's my strategy in sim? This one here, we could use that as shells. So maybe shell that out. This part here won't do it. So there's definitely a mixed mesh. We need both the best worlds. This part here definitely could. Let's just do one more, and I'll show you what this is. It gets pretty cool. So if you are doing design where you're working with just a ton of stock, sheet metal, sheet metal actually automates this whole process, but we don't have to get into that. What you can do is create this in context assembly, start to create these offsets. And if we open this up, we now have this really nice variation coming together. So I could go through and actually start building the whole thing up as a surface body. Now I've got this to kind of use as my sim model. And if it's all uniform thickness, I could have skipped that whole defeaturing part because I'm just saying what I want for simulation.
So opening that part is a good way. I can imagine if you step away from your computer, either grab more coffee, hit the restroom, whatever it may be, other distractions at work, you come back, it's like, how do you know where you left off? Mm-hmm. And, we were talking about, we talked about some of those model edges earlier. Right now they're blue, and that's kind of the default color. Can we take a look at how, a SolidWorks user would change those open edges? Taking a look back, there was some... We've got a bunch of different colors that popped up. Salmon. You could do a salmon color. We could do bright blue. It's kind of we kind of have a bright blue there already. Bright yellow for open area edges. That came from Eric. Yeah. That's my pick.
Yeah, Eric.
Let's go for a yellow. Yellow stands out really nice.
So this actually, I learned this tip. This is one's been around for a while. A lot of the power users know it. Jordan Tadich on our team taught it to me, who's a power surfacer. This guy knows sub-D, knows surfacing. So even if you're not doing this type of thing, inside of your system options under colors, there's a lot of cool colors you can change. There's some current color schemes you can modify just to do like a bulk. But I always recommend, poking here. Some people like to change like the overdefined sketches to it. Scrolling down, and let's see if we can go without flying past it. Oh, no, went past it. You'll see the surfaces, open edges. The default is this funky blue that really blends in. We were laughing about gray, right? Would be the only thing worse. So salmon is like, what do we got for? Is it more of a pinkish?
Yeah, like a tan pink, I think.
I don't even know.
If anyone knows the RGB value, type it in the chat. Yeah. You can do custom RGB values there.
That's probably close to salmon.
Yeah,
I don't know.
Let's go with that.
Kind of orange, more oranges. But what's really nice about this is when you set those, is now we get a much better contrast on those surface open edges. Super handy, especially in surfacing tools. Again, you want to close those when you're creating watertight models with surfacing tools. This is a nice visual indicator just to tweak so you can check the model. In this case, to your point, Michael, I leave, I go get coffee. I could open that part or I could just say, hey, I can see where all these surfaces have been created.
All right, Mike. So we got about 20 minutes left. Let's keep moving forward here, and because we're still under this time crunch, right? We need to get to those results as fast as we can. So what's next?
So here was kind of going back to the workflow I developed or helped with this guy that Jesse, when we were trying to figure out how to quickly do this. So we've got something that's ready to go, but now we have things like small little holes that may cause problems. You'll notice that we've got some embossing in here. If you really get into the model, if I can show you some examples, there's tons of these little fillets that are going to cause problems with meshing because it's going to want to use a tiny little element to fill that. That doesn't matter in the grand scheme of things, So getting rid of those is really my next step. And since we're in an assembly mode, we'd have to open the part, create a configuration, tweak it, or just, I guess we're in that pack and go version. So what I like to do, and again, going fast, going quick, getting this is just saving this out as a SolidWorks part. So if you're not familiar, files save as, you can convert an assembly to a part file. And what that actually will do, and I've got one already done, so I'm going to just jump over here, is that converts it to a multi-body part. In
There's
this
something
case,
really interesting that happens there. We talked about this before, but just kind of keep us going here. When you do that save as part, it's only saving out what is shown.
Mm-hmm.
So all
that was
those
the
things
aha moment,
right? That everything that you hid does not get exported when you do save as part. Huge.
Yeah. So
awesome.
what we were doing up to that was going into your selection tools and saying select hidden and doing a bulk suppression. And then when we tested it without that and realized it doesn't matter if they're not shown, if the geometry is hidden, yeah, when you save it as a multi-body part, it only saves out the bodies that are shown. So that completely like validated our no suppression technique, made it a lot faster to get to this thing, which is our almost sim ready model. So Michael, the next thing really is getting in and like, oh my God, I still have some work to do, but this is all easy stuff, right? We can come in and start to visually look at here. And I'm in a part environment. So creating a sketch, I don't need these, this embossed number. This has got a like 10,000 inch, not even cut to it. So let's just get rid of that. I'm going to create a sketch. Let's see if my sketch is working and start to actually just, that's weird. Defeature this with just standard, bosses and extrudes and so on. The other tool I'll use a lot inside of here, and I'll point this out, look at the assembly tree itself. But because we did this export as a part, we lost the features, and I don't care. Okay. As a sim guy, I still have the geometry in a more complex form that I'm getting simplified. So if you're not familiar with things like going through and doing a delete face, like this edge here, we may not need. The direct editing tab is awesome. This has got so many awesome features inside of it. Let me get out of that sketch. And we can just blast out faces. So I'm going to do a delete face on here. Let's see, is anything else I don't need? This is not selecting. I'm not sure why. And you can basically start cranking these out. So let's look through the simplifications that I actually go through. And we'll roll this forward. And I'll show you.
I think delete face is one of those that's great. It's a common direct editing tool. I know I used it even on the Simulia side when I wasn't able to use some of the automatic, feature simplification of the model. But yeah, delete face. And I think even, you can delete holes as well as some of these surfaces, right? There's a lot of these bolt holes and type of things that we may not necessarily need in the model. So that's, yeah, I think those are some great techniques to just kind of simplify the model, get rid of some of those small details that are just going to, increase the solve time, but really not impact the results much. And of course,
so oh, go ahead.
I was just gonna say, because again, start simple. You can start with a very, very simple part, and then you can, again, crawl before you walk, before you run with simulation. You can then add additional levels of complexity. So if, to understand if some of these, maybe if they're lightning holes in the model, how much do they actually influence the structural stiffness?
Yeah. Great stuff. In terms of that, as we're simplifying, we're adding a feature to this multi-body, basically an imported multi-body part. And if you go through and maybe delete a fillet and say, well, I don't know, doesn't make it, or a hole, does that make a difference in the sim results? You still have a feature that you can suppress, remove that out, and do those if then studies. So, it's you still have that on and off switch. So I just ran through, did a bunch of, boss extrudes to get rid of the some of the serial numbers on here. A great tip is if you have holes, like I had a bunch here, select on the edge of the hole and click delete, and that'll actually just delete out the hole. Or Michael, you showed me the other day, they actually added delete hole to the surfacing tools. So if you have a surface body with a hole in it, you can click on the edge or use this tool, and that just does a boundary surface fill and just fills it in, knits it, and done. So the process really is kind of having fun here, coming through. I deleted out the bodies of each of the flanges, really started to walk through and figure out where I was getting issues and not. all along the process of doing this, the other tool that I love, and I swear by, there's two more that you guys all know, but did you know that on the evaluate, that interference detection, which used to only be supported for assemblies, and Michael, do you know the release? Does anyone know the release that
Yeah,
this is supported for bodies?
Chat, we need your help. When did we add support for interference detection to SolidWorks parts? All right, that's the question. The other thing I think I want you guys to chat in about is we're getting some good support for the direct editing tools. What technique do you like the most for making some of those direct editing changes to the model? So just tout those out. We've got a couple ideas floating out there for SolidWorks 2018, 2017 maybe. Feels like it was later than that. But yeah, being able to do some of those body comparisons, really good. And yeah, if Eric just called us out on it of a delete hole, because it is something that's been in the software, I think for a long, long time. It was just buried. You had to know that you wanted to hit delete on the keyboard, where there wasn't a button for it in the user interface. So it's a great tip there. So if you are using an earlier version of SolidWorks and you don't have that delete hole button, it's there. Just hit delete on the keyboard, be able to leverage that.
So inside of here, interference detection, now that it's supported in multi-body, this is another area that you can run into issues down the road. Now, this is modeled very well, but it's also modeled with things like press fits. Actually, where the connection is here, we have a tiny little bit of interference on here, which is causing me some issues. So with interference detection supported now for multi-bodies, I can go through and get rid of, all the small little things and so on. And I can also go through and check where we have these interferences and make modeling decisions as needed. For like press fits, we can simulate those. So if you want to look at the stresses induced by that in simulation, but for an overall structural run, I may not care as much. So things like a move face, if I zoom way in, maybe on this face, we just want to move that out, 100,000th of an inch. Or what I like to do is just use some of the Boolean operations in direct editing. We can do a combine and actually subtract, which is a great tool. And that's what I did here is I would create a copy. So here I have this is going to be my cutting tool. Think of that whole big plate. And the copy command is just inside of our, again, direct editing. We have move copy bodies. If you guys aren't aware with this is pretty cool. You can actually create mates with bodies if you hit the constraints button. So there are mate settings to be able to do some basic mates, coincident, parallel, and so on. But in this case, like, I don't want to translate it. I don't want to move it. I just want to say, let's copy this thing a bunch of times over, and I'll create however many copies I need. So however many interferences you want to get through. So that move copy, this actually created two variations of it. And then I'm just using a subtract, which then goes through. And I just select this as the subtracting body when I want to remove the material. And I get rid of that interference. So in like a bearing, which is pretty easy, an extrude cut would work. A move face would work. But you get more complex interferences that might be happening, and you're in a multi-body approach, copy that cutting body however many times you want to make a cut, because it deletes it. And then you're just going to do a combine subtract, gets rid of those all. The trick for that in an assembly is if you go through and you're doing a simulation on an assembly is in the mold tools, you can create a cavity, which does a in-context reference and knocks it out. So check out cavity is another way to get rid of interferences in mold tools. So I just basically went through and did a bunch of these where I found them rolling through. Every now and then I'd go back and just do that interference detection and check it out. I actually just added that right to my little heads up keyboard, because you can add it to there now, which is, when was that added? I don't know. That is awesome.
Well, and if you wanted to customize it, right, you could just right click there in that toolbar, choose customize, and drag additional buttons and shortcuts that you want. Yeah, way easy way. I know it's like every year, every release of SolidWorks, I feel like we do incremental things to improve the user interface of SolidWorks. And I feel like I challenge myself every year of like, you can hide the command manager, you can hide all your toolbars, because we keep improving, what's available right at your tooltip, right at your mouse, to execute some of these commands.
So yeah, that's walk through, check the interference, create some of those copy bodies, make some cuts, however you need to do it. Really, this is the goal, is get down to no interference. And then at this point, everything looked pretty good, but I always like to do the other one that you use throughout here is the check bodies. You'll notice I added that to my heads up toolbar. So we can run a check. Really what I'm looking for is this minimum radius of curvature.
Yeah. Okay.
All right. I run that. There's a bunch in here. And we can start checking these out. All right. Some of these values, I don't know if you guys can see those, but 3,000, not too bad. But you get into this. This is 2.6 e to the negative 16. Whew. That's tiny. Not going to mesh very well. It's actually use the hole wizard. That's just through a tap end of a screw there. So delete face, right? So I can start to use this again, go through, I find those out. I'm letting SolidWorks figure out where they're at, do a couple more delete faces to it, get a little bit further. All right, where am I at? Let's run another check. We'll check this out. All right. Oh, we got to turn on minimum radius of curvature. There we go. That didn't seem right. But now at this point, I'm just really looking to see, do we have any of those really small numbers? 2 inches, 1.5 inch? No, looking good. Cool. So interference detection at this point, check geometry. This check entity tool is great for like imported geometry. I run it all the time with that. Someone's handing you a part off, surfacing geometry that may be good or bad. Run this. You can take a look. Really, really easy way to analyze. All right, Michael, that's pretty much where I get to, right? We've gone through, deleted a bunch of faces, and in this model there was tons of little tiny chamfers and little tiny fillets that were all brought in here that we don't need in sim.
I feel like the end is in sight. Are we ready to do a little simulation on this?
Yeah, so let me jump over, and I'll walk you through the basic setup. So again, the goal here was to get the final stamp of approval saying this thing will meet it's actually was an under the hook, ASME under the hook factor safety, which by the ASME manuals 3-to-1, this company did a 5. They wanted to be at least 5 on their load. At this point, it's defeatured, so I'll start my study. I always do a draft mesh run, apply my materials inside of here, and this is how it came in, right? I've got all of these surface bodies are automatically created, so I don't have any work there. SolidWorks surfacing tools makes this a little bit easier. As Michael had mentioned earlier, you can still convert here, but don't have to, right? Those are all done. I've created some fixtures. I put those up top here. That's where it's being loaded from the top of the arm. 30,000 pound force. So we've got a big beam that we're going to be moving up. That maximum peak force is what we're solving for. Will it mesh? Should we try it live?
Will it mesh?
All right. We're going to try it live. So then we go through, and really what we want is making sure that this thing will mesh. There's some great tools built into the mesher. We have different variations of meshes to try. A lot of times it's just leveraging things like that check geometry and just saying, what's the smallest radius you got? And that's often a good place to say, that's the smallest element I want to use.
Yep.
If you're using plates that have ununiform thickness, you always want to have at least 3 elements through there, so you can measure those and say, well, my thickest plate is 2 inches, 2 divided by 3. That's the smallest element I want. Again, this is all taught in the sim class, and there's plenty of discussions around it. But my goal was to be able to create a mesh pretty quick. We're at 40 seconds, and so far it looks good. All right, cool.
Look
so
at
we
that.
got
Beautiful.
the mesh.
Just want to shout out real quickly. Andy Barnes brings up a good point. Why? If you're doing shell or offsets, or maybe you're doing some plastic parts where shell offset surfaces where sometimes it fails, that check entities tool that you showed earlier is a great way to look at what's the minimum radius of curvature to easily identify some of those sources in the geometry, why it's going to cause some issues. The other thing, the other question, that comes up here is like when you have the mesh, we see in the simulation tree there, a lot of them have materials applied, with the solid part thicknesses are automatically accounted for. But with those shells, those surface bodies that we were working with, we have to define that thickness value.
Mm-hmm.
Right. And I think that's one other reason it's interesting, with the way this was modeled up in the assembly, was sheet metal used to model those components? Probably not.
No. Yeah.
Because that's another smart
all
thing.
Weldments.
Yeah. All weldments. That's another smart thing that SolidWorks does in SolidWorks simulation is if you model some of these plate parts even as sheet metal, SolidWorks simulation automatically grabs the thickness and treats it as a shell. So that's a great way to leverage some of that lightweight technology.
Another thing with that I really appreciate, and actually going back to this customer story where they're doing sim at the end, started to introduce it very in their design process, and they actually were able to reduce these, like that 2-inch thickness is not 2 inches anymore. Their factors of safety were really high, and they saved a lot of money on just like on shipping alone. I think was an insane amount of money on just the raw material by changing those thicknesses. So even though the sheet metal offers some automation inside of here, when we look at these shells, since I'm saying, I grab my notepad, I look at, yellow was 0.5, green was 0.75. This was I think like 2015, but the shell manager is a nice way you can open up, and then you can start to do if then scenarios saying, hey, you know what? Let's change all the 0.5 to 0.75 and see what that does, or 0.4 or 0.2. And you can actually modify these and say, what is our optimal plate thickness that still get us to our design requirements or factor safety requirements.
Reminds me of that color coding too, where we have thickness and material. There's excellent options there to group these components visually to understand what's going on in the model visually.
Yeah, and this is actually where I got that color coding idea was from here. I thought, well, why can't we do that in the CAD side first to organize this? Because this does it automatically, which to me, really powerful way to do it.
All right, Mike, so let's start to wrap this up. The outstanding question is, did we hit our factor of safety requirement?
Well, let's take a look. So we were going for a minimum factor safety of 5. And if we do this at a global level, so close. 4.89. 4.89. I think I changed the material thickness somewhere, but now I know we can go through. I can toggle some of those thicknesses of some of the of the flanges, see if going up or down, or change material if then scenarios, and so close.
Awesome. Well, great. Well, I think and that's the thing. It's like, well, we can't change the design, but is there something else if it is thickness? Thickness change, or maybe a material, for instance, that you can toggle between, because there's, creating a design is challenging. It's not a trivial activity. There's a lot of requirements to meet. If it's the size, if it has to fit inside a certain space, how can you achieve, some of the safety factors like we're trying to achieve in this case? So, great workflow, Mike. Not surprised. I knew you could do it, from bringing us from a complex model down to something simple, lightweight that takes, that solves very quickly inside SolidWorks. And this is SolidWorks simulation here, available right onside SolidWorks desktop. Also in this version of SolidWorks Connected, that's built on top of the 3D Experience platform. So great work, Mike. Any last comments before we wrap this up? All right.
I've got some comments.
Yeah.
I think the big thing with this one is there's a lot of different ways to get to the end results. This is, take what you can, grab some of the features that I showed, the pro tips that I showed, use them as you need, and start to play with your own ways to get to this result. But hopefully you guys learned something, and just thanks for tuning in. I'm happy to share, and I love sharing this stuff with you all.
Yeah, we'll look forward to having you back. In fact, let's talk about what's coming up next with SolidWorks Live, exploring 3D Experience Works, and the next episode of SolidWorks Live Design. So next week, April 22nd, Jeremy's going to be back as the host of SolidWorks Live. He's bringing on Paul DeWise so you can learn how to optimize your CAD designs for 3D printing. So today was kind of, optimization for simulation. Next week, optimization for 3D printing, and bring on an awesome manufacturer, 3D printing expert, Paul DeWise, to explore that so you can learn that side of the optimization. The following week on April 29th, and exploring 3D Experience Works, we're going to be covering multiple design apps right in your internet browser, right on the clouds, leveraging some of the powerful design apps on the 3D Experience platform. All right. And then in May, Mike, you and me, we're going to be back in May with SolidWorks Live Design. I'm going to be getting more into simulation, and you are going to be showing your skills with photorealistic rendering. So that's going to be some awesome stuff, jam-packed the rest of this month and in May. We look forward to seeing you again. Thanks, everyone, for attending this episode of SolidWorks Live Design. And be sure to jump over to the SolidWorks YouTube page to make sure you're subscribed and take a look at some of the other playlists that we have available for you there. So in addition to be notified when these episodes come out, make sure you're following us on Instagram, on Twitter, LinkedIn, and follow us to get some of these latest news and updates. And we'll see you in the next episode. Thanks, everyone.